Good afternoon, everyone. Welcome back to the channel. Today, the topic is chi-square test or chi-square analysis. So chi-square test is used to determine whether there is a significant difference between expected and observed values or frequencies in one or more than one categories. So a typical question of a chi-square test will be, does this data fit blank ratio, let's say in genetics? So let's say the question is, does this data fit 3:1 ratio? That will be our research question. So as you see also here in the shared document, you can see the detailed explanation of this step by step. There are 5 steps. The first step is we need to form a hypothesis, a null hypothesis, which we call H0. So our null hypothesis will be data follows 3:1 ratio. Then number 2 step is basically we need to construct a chi-square table with data given and then calculate expected frequencies and then finally calculate chi-square calc value. So we will need that value. So we make, as you see here, we make 1, 2, 3, 4, 5, 6 columns. So we have, and the question actually, so is 3:1 is 3 green to 1 white. So that means there are two total phenotypes. So we will have 2 rows. You can see here, green and white. And then these are numbers already given us. Observed numbers are 740 for green plants and 260 for white plants. So we need to just step by step calculate and fill this table. So observed values already given to us. And then we find the sum of these. If we add these two numbers, is 1000 in this case. That's our sum of this column. Expected values or frequencies we need to calculate, which is the value here, the total sum value of the column total times expected ratio, which is 3 out of 4, because 3:1 means 3 out of 4. We multiply by 3 out of 4. In this case, 260 times 1 out of 4, because 3:1 means 1 out of 4 also for white or recessive, times 100, which is the column total. So if you calculate that, this will be 750. The second row will be 250. If we add these together, sum will be 1000. Now we know we actually calculated correctly because the sums of observed and sums of expected columns are the same, 1000. Next is pretty straightforward. Observed minus expected. Observed 740 minus 750, which is 10. Here 260 minus 250, which is also 10. And then next column is take squares of this column, which is 100, 100. And then last column is divide this previous column by expected column. If we do that, we get 0.13 here, 0.4 here, and we need to find the sum of this column, the last column, which is 0.53. This is our chi-square calc value, or chi-square calculated. Let's hold on this, and the next step is we need to find out what's our critical value of this statistics or chi-square given, which is also given in the exam. So this is 3.84. This is we call chi-square table value. How this is found? It's from the chi-square table. You need degrees of freedom to find the right column. Degrees of freedom is n minus 1, which is number of rows, minus 1, 2 minus 1, 1. If you go that table, find the um, find the row 1 and go all the way to the 5% error, we see this number 3.84. But this will be given to you. Now we have everything. Step number 4 will be the results comparing our chi-square calc value to chi-square table value. Okay, so if chi-square table value is larger than our chi-square calc value, which we accept our hypothesis. So in this case, if you look at chi-square calc value, it is 0.53, chi-square table is 3.84, we definitely accepting our null hypothesis. If this was other way around, if the table value was smaller than calc value, then we had to reject it. But we accept it because our table value bigger than our calculated value. And then finally, the final step is step 5, which is state your conclusions. So we go back to our hypothesis. What we accepted? We accepted that data follows 3:1 ratio. So basically, our conclusion is data follows 3:1 ratio. So this is a chi-square test. Again, this is used in genetics extensively. Um, as always, if you have questions, please stop by office hours and reach out to me. And see you in the next video. And best of luck with your studies.